Hello students, my name is Dr. Gajendra Purohit. Welcome to our YouTube channel. If you are pursuing B.Sc or engineering or preparing for any competitive exam, where higher mathematics is asked, our channel is very helpful for you. So today in this video, I will explain another method within total Pfaffian differential equations. That is, if the given equation is homogeneous equation, then how do we solve this? We studied homogeneous in the first order, first degree equations. For instance, if the given equation is not homogeneous, we multiplied it by an integrating factor, right? And we used to solve it if we had some particular condition being satisfied. Then we used to solve it directly. The same concept will be applied here. So let's start. So first let's talk about the process of solving this. Whenever we are given any homogeneous differential equation in a question, so what will we do first? We will check the integrability condition. We will see if it is satisfied or not. Now you might want to know, what is this condition? If we encounter any such equation where condition is anyway satisfied. But for instance, if it is given that you need to satisfy this condition, we first need to satisfy that condition. Then a question might arise in your mind, what exactly is this condition? So let's say we have an equation p dx plus q dy, plus here it is given r dz is equal to 0. If we are given any equation like this total differential equation, then what do? We write p, q, r, and then in this way we will write x, y, z. Then the condition we have is p multiplied by this is del q by del z, and then it is minus del r by del y plus. Then we get this as del r divided by del x, and here this becomes minus del p by del z plus r into, here we will get this as del p divided by del y, and then minus del q by del x is equal to 0. So if this condition is satisfied here, this means that the integrability condition should be satisfied here, and also its value should become 0, right? After that, what do? We calculate the value of px plus qy plus rz. If this is becoming 0, then we can solve this directly here. It means we don't need to find the integrating factor. How do we solve it? Firstly, we will check if px plus qy plus rz equals 0. If it's equal to 0, then we don't need to find the integrating factor. We will put x is equal to uz and y is equal to vz. Then what will we do? We will solve it. I will tell you what is the process. If the value of px plus qy plus rz is not equal to 0, then we will have to find its integrating factor. That would be 1 upon px plus qy plus rz. What will we do next? We will multiply this given total differential equation with this integrating factor. And then later I'll explain what is the next process, how to do it. Hence, ultimately, we have two types of equations which are asked regarding this method, whether the value will be equal to 0 or if it won't be equal to 0. When it's not equal to 0, we get the integrating factor. Let's see this question and I will try to explain through it. Suppose we have an equation given as yz square, x square minus yz. Let me explain to you, this is given yz square. X square minus yz multiplied by dx plus x square zy square minus zx, and then here we are getting dy plus xy square into z square. Then minus xy multiplied by dz is equal to 0. First, we need to find out if this is homogeneous or not. The concept of homogeneity is that the degree of all the terms should be the same. Look here, the degree of all of these terms here is same, it is 5. When this will be multiplied, it will also be 5 degree. It means 5 degree term. So this is homogeneous. Now what we will do here, px plus qy plus rz. We will calculate value of this. What we will get? As value of this has been given. We will multiply this by x. When you multiply by x, then this will become xy. Z square into x square minus yz plus multiply this by y. So it will be x square zy. And then this will become y square minus zx. Plus this term here, this is r, we will multiply this by z. So on multiplying, this will become x, zy square multiplied by z square minus xy. Now we will find its value, right? So you can see we have xyz common from these, right? You can see all of the terms have xyz. We can multiply this by z because one z will be left in xyz, right? This will be zx square and minus y. Z square, what will we do? This x will be multiplied with this. Then plus xy square minus z. It will become x square now, y is left here. If we multiply by y, we get yz square minus xy square. Now let's see. if this term is getting cancelled or not. You can see that this zx square is getting cancelled here. Yz square cancels out. This term is also cancelling out. What value do we get? We are getting 0, and whenever we get this value, when we get 0, then what do we do? In that case, we assume x is equal to uz and then y is equal to vz, right, students? It means we need to substitute these values for x and y in place of dx. And in place of dy, we will put these values. So what will be the value of dx? It will be u dz, plus it will become z du, and the value of dy, which we will get here, it will be v dz plus z dv. Students, now what we will do? We will substitute all these values here, right? So what it will become in place of y? We will get vz in place of y. Wherever it is z, there we keep z. So it will become vz into z square into x. This will become u square z square minus. And now next we will get this term as vz square. Is it clear? Multiplied by dx. So the value of dx that we get is u dz and plus z du. This is slightly difficult. What is the next value that we will get? This value will be x square z. Since it is x square z, this will become u square and it will become z cube because z is already there. And then we have y square here, which is v square z square minus. Then next we are getting is x z here. Minus this term will become uz square, clear? And then dy. The value of dy will be v dz plus we are getting this term z, dv, clear? Plus in this next, here we have x and y. This is x and this is y. We will multiply both of these. So u, and since it is y square, this will become v square and it will be z cube. Then z square will remain as it is, and when we multiply x and y, we will get minus u vz square. It will be multiplied by dz. Now what do we do here? Look here, we are getting z cube common from all of them, right? Next, if we will notice here, then z square is common. And here we have z cube, so I'll take z to the power 5 common. There's not much space left. I think it will be a problem to write further. I will do one thing, I will write it above. Then I will have to erase it. The question is solved from this point. We have already checked the condition. We have got this 0, so we don't need this part. Now I will solve this here, right? If you look here, we have z to the power 5 common from all terms. This z square will go inside and this is z cube. So z power 5 will be common, right? If we take z to the power 5 common, we will get v. And u square, so write v. U square here, we will get this value. Then we will get v and v, hence it is v square. So minus, this value will become v square, right? Into the next value that we are getting, it is u dz plus, from here we are getting z du. We get this value, clear? We have already solved this first bracket. Now second bracket. We have taken out z to the power of 5 common. So it becomes u square v square, then we get u square v square, right? Minus this term will become u cube. We will write this, and then next we will get v dz plus z dv. This will be the value as z5 has been taken as common. Next, we will take uv square inside. Then here this will become u v square. This will be multiplied inside, so this will be u square v cube minus u square v cube multiplied by. It will be dz. What will be this here? It will become the term here. Is it clear? Let's proceed and we'll try to solve it here. Now let me tell you what we will do. We will write du, dz and dv separately, right? So that the question gets solved. Let's see here. We are getting this as the term of du. Now let's do one thing. Take this z5. We will take it to 0. z5 became 0. When we will take another z here, then this will be z and then I think v. U square minus v square multiplied by du. I have already written the du term. Then I will write the dv term first. We have z common. So let's take it common here. This will be u square v square and minus it will be u cube. Into it will be dv, right? Now we'll take out all the dz terms, right? So this will be dz term. And we will multiply this term with u. It will be v. U cube minus u v square. We will have a dz term from here. Then we will get plus u square from here. V cube minus u cube v. And from here we will get this term. So what I will do? I will write u times v square minus u square. V cube multiplied by dz. This will become a term in our expression. Now check, some terms will cancel out. You can notice vu cube and vu cube are cancelling out. You can see which terms are getting cancelled. and this term is getting cancelled from this term. U square V cube is cancelling out. This term is also getting cancelled. It means all the coefficients of dz will become 0. Is it clear? Now I will clear the screen a bit because we don't have much space left. So I will erase the screen to make space for solving further, and we will be able to easily solve it. Let's proceed. Now this term is left and z is left. What we will do? We can take z to this side, we will take it to 0. So students, we will get this as vu square minus v square, and then next we will get du plus u square and then v square and minus u cube. Here we have this dv, it will be equal to 0. Let me tell you again that we started with x is equal to uz and y is equal to vz, and we have done the calculation up to this point here. We will move forward, and here we will divide this by u square v square, right? Wherever we have u square v square, we will divide. Write it here, divide by u square v square. To solve it, we will divide by u square and v square. If we will divide this, we'll get 1 by v and minus 1 upon u square du, plus here we'll divide this. So this will become 1, and here we'll divide this. Then we will get minus u divided by v square dv is equal to, it will be 0, right? We can see it is directly integrating. Therefore, we will get this as minus 1 upon u square du is directly integrated. It is also becoming dv. We have few problematic terms here. Let's do one thing and write it. So 1 upon this will be v. Du minus it is u by v square. It is dv. Clear, students? We have its value. You see, there's a problem in doing the integration of this. The rest of the variables are separated. Now, if we solve this, we'll get 1 upon u square du plus dv. And what will I do next? I will take the LCM of v square. So we will get v dv minus it will become u dv equals 0 and equals 0. Now we can directly integrate it. We will get minus 1 upon u square du plus dv. Now next, if you will see, it is d. Here you can notice that we are getting u by v, right? When we write it like this, here we will get a constant term. Now what we will do? We integrate this term. So we know here that the integration of this minus 1 upon u square is minus 1 upon u. This will become 1 upon u. Plus this will become v. Plus we will get this as u by v is equal to c. And we have assumed this value. So we know from here we will get value of u as x by z, and the value of v is y by z. So if we substitute this value, we will get z by x plus y by z. And if we divide this, then we will get x by y is equal to c. Now we take the LCM of x, y and z. When you take LCM of x, y and z, x gets cancelled. Y, z, and this will be y, z square, and z is getting cancelled here. So this will be xy square. Y is cancelled here, so this will be x square z equals to c. So cross multiply this. You get yz square plus xy square plus x square z equals to c xyz. So what we will get this as? It will be the solution of differential equation. In this way, we can solve it very easily here. Now I will do another question for you. See, I've explained the method here. We have this question, and I'm going to explain if the value of px plus qy plus rz is not equal to 0, then I will explain that what do we do in that case. First of all, it is homogeneous equation of degree 2. So we know that we have px, qy and rz. Now p will be this. This is q, this is r. So we'll multiply this by x, this by y, and this by z. And if we simplify it, we will get this value, right? Now we will factorize this equation a bit here, right? And then we will get y into x plus z into y plus z. Am I right? We will consider this as I. I told you, if in case we don't get 0. Then we get 1 upon px plus qy plus rz as integrating factor, and we consider it as I here. This means we will multiply this by 1 upon I. In other way, we can say that we will divide this by I, right? Let me explain it again. This means that the value we will get, we will divide it by the integrating factor. Either multiply by 1 upon I or divide by I, it's the same thing. Clear? But there is one problem. Dividing this by I does not separate the terms, leading to complicated integration because of such a large value in the divide. How will we do integration? So we will use one trick. I'll try to explain that one trick used here. The question that is given, what we will do? We'll divide that equation by I. And what are we going to do with the value of this I? We know the value of I, right? Tell me what is the value of I. Y. X plus z multiplied by y plus z. This is the value of I. Students, now we will consider this as I. we will differentiate this because we have 3 separate brackets. So we will solve each one of them separately. First differentiate y. So it will be xz. And y plus z, this will become dy. Then we will integrate this. This will be y, this will be dx plus dz multiplied by y plus z, then we will leave this. So we will get this as x plus z, it will be multiplied by dy plus dz, right? What will it become at this point? It will become a term. Now this will be di. Now we know if we solve this di, then we will get one equation of this type, right? You might ask how it will be formed. So look here, let's take the coefficient of dx. So what is the coefficient? Y into y plus z, on multiplying it will be y square plus yz into dx. We got this value on multiplying with y. Now we need xz plus z square dy. Hence, when we multiply this x by this, then this will become xz. And when we multiply this by this, it will become z square dy. Now, the remaining term that is left, x, will be multiplied by this as well. So that will become xy here. Plus, this will become zy dy. We have separated this term and this term is also separated. And let's write it down, this remaining dy as well, to solve it easily. This will become yx plus yz into dy. Now this dy is done here. Is it clear? Now let's talk about dz term. In this dz, we need y square minus xy, right? We can notice one dz term is given here, right? And one dz term is given here also. We need this term y square minus xy. And we are getting this y square here, right? So we will write this y square. And then we will get this as dz. But we need y square minus xy dz. Since there are no negative terms in this expression, we can see that we are getting y square dz. But the rest of the terms aren't forming, right? When we will multiply by this, we will get one term, and if it's not forming, we can just write yz and dz, right? And we have another dz term here. I'll just write it down. Then next we will get yz. And then we will get this dz here. I hope it is clear. But now what do we need? We need minus xy dz. What will I do, students? I will add xy dz and then subtract xy dz here, so that this equation becomes a little easy in solving it further. I hope this step is clear to you. Let's simplify it. We will get y square plus yz dx. Plus this will be xz plus z square dy. Now what we will do next? This term dz. We will solve this dz term first. We will write this dz. I am sorry, we will not take this term. We will take this negative dz term. This will be y square minus xy dz. Now let's take the remaining terms. We have already taken this term and this term. Now these two dy terms are left. We will take both of these common. So what we will get on taking it common? Xy and xy will become 2xy, right? And yz. We are also getting this yz. It will be 2yz dy, right? Since we have taken this dz term, so one term of this dz is left, and this term and this term. Now yz is also becoming twice. We are getting 2yz and plus I think we are getting 2xy. 2yz and 2xy. It will be 2xy multiplied by dz. Hence in this way we will get the total value. Now pay attention, the value of this which we get, it is this here. We are getting this as the value of the equation, right? This is equal to this. Now you need to pay attention what will we do here. So you might notice that the value of I which we have at this place, are you following me? So we divided that. Now you can see this value that is here, right? You have this value. So students, what will this value be equal to? This will go to the other side. If I write its value, what value will we get? This term's value will be equal to the di minus this. What it will be? Di minus this. If we subtract, then what will we do? We'll take 2 common, y is also common. We will get x plus z dy. Minus 2y x plus z dz, and this I will come below. So as soon as you divide the term we get here, what will it be? Pay attention. This will be di, and then the value of this term here, we kept as di minus this. I will do one thing, I will take 2 common, and y is common from here. It will be x plus z into dy. And these two terms, they will move to other side. This will become minus and this will also become minus. So we will take 2y common. We will get z plus x. It will be multiplied by dz, right? We will get 0 in equal to it. And because we are dividing by I, and this will be the value of I. So let me write it, y. This will be x plus z multiplied by y plus z, right? Let me explain it again. We divided it by substituting the value of I. We had to divide this by I. The value of this term in numerator, we obtained it by subtracting it from di, right? So we subtracted this from di, and this is the value of I. Clear? So we did nothing, just substituted these values and solved it. But pay attention, what will we get when we will put this? It is di divided by I, and now I will put I in the denominator. So now I will take these two to the other side by dividing, right? When I divide and take it to the other side, pay attention what we will get. We will divide this separately when we will divide this term. So y plus x, z will cancel out. Students, then this will become 2 dy. Upon it will be y plus z. And when we divide this by this, then y and z plus x will cancel out. Then in this case, what will be the value we will get? The value we will get will be plus 2 dz. Upon y plus z, we will get 2 common and we will consider y plus z as t. When we integrate this, what will be the value we get from here? If you will notice here, we are getting this log I. Now what we will do? We will take out 2 common, then in denominator. The value we get, we can write it as twice of. And dy plus dz. By y plus z, if we consider the term below as t, numerator will be dt. We will get log y plus z. We will consider n plus log c, it will be better. So students, then we will get this as log I is equal to 2 will go to the numerator, so it will be log c multiplied by the whole square of y plus z, right? Now what will be the answer? The answer we will get is I is equal to c y plus z whole square. We will take the value of I and put it here. And then we will get y multiplied by x plus z into y plus z. This is equal to c y plus z whole square. Y plus z and y plus z will cancel out. So y x plus z is equal to c y plus z. This is the solution of this homogeneous differential equation. We can solve it in this way. I know it's a bit complicated, but this is the method. Now I will take another question and I'll try to explain through that question. If you didn't understand, then this question will make it easy to understand the method. Here the value of p that we have is given as yz plus z square. Here the value of q we have is given as minus xz. And the value of r is given as xy. Now we know that it is homogeneous with term of degree 2, px plus qy. Plus rz we will find the value, multiply p by x. This will give us xyz plus xz square. Now multiply this by y. So minus xyz, we will multiply this by z. Plus it is xyz. Now you can see that this xyz is cancelling out, right? Now what do we do here? So we will cancel out xyz. And then if we will check here, we are getting the value of px plus qy. Plus rz, its value is this one. What I will do? I will take xz common. So this will be y plus z, and what we will do? We will consider this as I, right? When we do not get 0, we consider it as I, and this becomes integrating factor. But I told you, whenever we will take it as I, then we need to differentiate this because we need to divide with I. I will explain it what we have to do. What we need to do with yz plus z square multiplied by dx minus this xz into dy plus xy dz is equal to 0. Ultimately, we need to divide it by I, right? Sometimes dividing by I becomes difficult. So we try to find the value of this term in numerator. We will calculate the value of di, right? We have these 3 terms. We will differentiate them separately. First differentiation of x. So this becomes z into y plus z. It will be dx, then we will do for z, right? xy plus z multiplied by dz, then differentiate these two, right? xz, this will be dy plus dz. It will become easy this way. Now I told you that we need terms exactly like these here, right? So that we don't face any difficulty in solving it, we'll do di is equal to, first term is yz plus z square. What will we get? Here we are getting z square and one term is zy, right? So we will write down this zy here plus z square multiplied by dx. The next term we need is minus xz dy, right? Although here we are getting this xz dy term here, but here I need it in minus, but we are getting it in plus. So what we will do? Let's write xz dy. Now I need dz. First we do one thing. We will write this xy dz, right? Let's write it here. The rest of the terms is z dz, and from here we are getting xz dz. We will take this. Now since we need negative xz, right? In that case we will add one term and then we will subtract one term, right? So what I will do here? I will write minus xz dy plus xz dy, right? I have added plus minus in this equation. Let's proceed. Now we need to solve this. So di is equal to, this will come zy plus z square dx. I will write this term, as minus xz dy. We have written this term. We will get xz. So now this xz and xz will become to xz dy. Now look, we need xy dz. I've taken xy dz. Here also we had xz dz. So students, what will be xz dz? It will become 2xz dz. Now you will notice that I have not written the terms in order. It is the first term, second, and this is the third term. Look here, it is this term minus this term plus this term, right students? If you notice, what are we getting its value equal to? Since we are getting the value equal to this, we need to put this value here. Now I will find its value here. So what I do is I take these two terms here. This will become di minus 2xz dy. This will become minus 2xz dz, which is equal to. This will become xyz square multiplied by dx minus xz dy. And then plus it will be xy into dz here, right? Therefore, we get this value. Now taking these two terms together, so we will substitute the value of this term here, right? Then what will this value become on substituting the value of this term here? Di minus, students, from here we will get 2xz into dy, then minus 2xz into dz. It is divided by what we will get here. This will be I equal to 0. I will put this I here. So di upon I. Now I'll take this negative term to the other side. What we are getting? We are getting 2xz common, and this will be dy plus dz divided by I. This is the value of I. So I'll write this down here. We will get xz. So it will become y plus z. Clear? Now you can see that this question is easily getting solved. Now see, this xz cancels out. Now we'll integrate it. So its integration will be log I, and this will become 2 log y plus z, and we take the constant as log c, right? This will be our log I is equal to this 2 will go to the power, and it will be multiplied by. So c into it will be y plus z whole square. Thus I is equal to c. This will be y plus z whole square. The value of I, we will substitute its value here. Therefore, we will get this as xz. Y plus z is equal to c whole square of y plus z, and y plus z square will cancel out. This will be xz is equal to c y plus z. We get this as the solution of total differential equation in this way. By applying the homogeneous method, we can solve this. If you are preparing for CSIR NET, IIT-JAM or GATE or any other exams like CU, ET, PG, so our books are available on Amazon and Flipkart. The link is in the description. You can buy it from there. We are launching many courses. On our Mathscare app, you can download the app from the link in description. This question is for comments. How long did it take you to solve it? Let me know in comments. And if you want to watch more such videos, then the complete playlist is available here. And if you are preparing for any competitive exam like CSIR NET, IIT-JAM and GATE, then you can watch the related videos from here. You can subscribe to the channel from here. Thank you. Goodbye.